So today we will start new lesson probability. Okay. So we must know first of all the meaning of the probability. Probability, if you see that in our daily life, we used to say it is probably raining today, or there are chances that it will rain today. So that means this probability means probability means what are the chances of happening something, chances, okay, or most probable, what whatever it is most probable that we used to say, it has a probability of this, like it is, there are chances or there is a probability that we used to say there is a probability that it will rain today, will rain today. So like this, the meaning of the word is chances. But when we measure the chances mathematically, okay, so in that case, we say that we can find the probability. What are the chances? How much chances? 50%, 60%. That measurement we find the probability. There are two types of probability. Actually, we have experimental probability. Probability has two types. Generally, we are dividing into two types. One is experimental probability. Experimental probability, and second is theoretical probability. Theoretical probability. We should understand the difference between the approach to probability. So one is experimental probability and another is theoretical probability. Actually, we have in ninth class we have experimental probability. In experimental probability, we can take one example for experimental probability and theoretical probability. For example, if we have a coin, okay, so coin, you know that if a coin is tossing, we can observe, we can do the experiment. First, we are tossing a coin, tossing, suppose we are tossing a coin 10 times. How many times? 10 times. So, okay. So, first point, what we are doing experiment. First, we are doing the experiment. What experiment? We are tossing a coin 10 times. This is our experiment, tossing a coin. Okay. Then, suppose we observe that first chance when we toss the coin first time, what will be the observation? There are two possible ways only, you know that, whether we get head or tail. Okay, so observation, we are having the outcomes, that is only possible two outcomes here, either head or tail. Okay. So we are tossing the coin 10 times. First time, second time, then we toss the third time. Okay. Like this, we have to toss 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, or and this is 10 times. So 10 times when you are tossing the coin 10 times, you are observing what will you get. Second time, then this is third time when you toss third time, when you toss fourth time, when you toss fifth time, sixth time, seventh time, eighth time, ninth time, and 10th time. Okay. Then we will observe total also. So that's why. Suppose you have tossed first time and you get tail, not head. Okay. Then second time you got head. Third time you get again head. Okay. And fourth time you get again head, then tail, then head, then tail, then head, then tail. So cross means you are not getting that. So how many times you got head? 1, 2, 3, 4, 5 times. 1, 2, 3, 4, 4, 5 times. So make it 4 times. Suppose you are getting this 1, 2, 3, 4 times. Head you are getting 4 times and tail you are getting 6 times. It can be anything. So this is the observation. Okay. And then we get the result. What result we get? We got outcomes. You can say we get outcomes. Head, we got the head. How many times head? 4 times. We are getting 4 times, not tossing 10 times. We are getting head 4 times and tail. How many times we are getting tail? 6 times. Okay. So this is called experimental probability because the question will be based on you will be given that a coin is tossed 10 times, we get head 4 times and 6 times tail. This will be the question. But we have done the experiment, observation, and outcome. So this type of probability is called experimental probability. Now we have to find the probability. Now we have to find the if we have to find the chances of getting head, what will be the chances of getting head? So that is called the probability. The probability of getting head will be equal to how many head? Favorable number of favorable cases 4 and total is 4 upon 10. Okay. Or if you multiply with 100, if you want to convert into percentage, you have to multiply the probability by 100. That means that will become 40%. So there are 40% chances of getting head. We got 40% of chances getting head and probability of getting this experiment we have performed. Now we are finding the probability of this experiment. So that is why it is called experimental probability. So probability, so that means the probability, the formula for probability is Number of favorable cases means we are finding the head. So the how many cases are favoring to head? 4 cases. So number of favorable cases, number of favorable outcomes or cases, same thing, favorable outcomes divided by total number of possible outcomes. Total number of possible outcomes. So here, if we are finding the probability of getting tail, how many favorable cases are 6 and total possible cases are 10. 6 upon 10, that is 60%, or you can write 0.6, or if you don't want to write in percentage, 60% multiply by 100. 60% chances to get tail, there are 40% chances to get head in this particular experiment. Okay, so this type of probability and the question based, so you will get in your course, you will get the questions based on the experiment. So because you have experimental probability, not theoretical probability. And in theoretical probability, okay, we can see the theoretical probability. In theoretical probability, we can say that, for example, if you roll a die, if you roll a die, so what are the possible outcomes? You can get 1, you can get 2, you can get 3, 4 can come, 6, 5 can come, 6 can come. So how many 6 can come? If I want to find the probability, we used to write this. Suppose this is A event, so we can say that probability of event A is equal to, if this event denoted by A getting head, so we can say the probability of A event is equal to 0.4. I will tell you event, and this is B 0.6. So if we have to find the probability of, this is theoretical probability, means when a die is rolled, find the probability of this. We are not having any experiment, but it is here, it is fixed that you will get the probability of getting 1. Answers are already known. If you want to know that the probability of getting one number, the 1 is coming 1 time 1 by 6 already. Similarly, the probability of getting 2 is also 1 by 6. Probability of getting 3 is also 1 by 6. So here the theoretical means its probability is already known. We cannot say that this will differ, because already we have one experiment which is known and which is giving the particular answers, particular probability of whatever. Suppose we have to find the probability of even numbers. So even numbers are 2, 4 and 6. There are 6 even numbers. The probability of even numbers will be equal to even numbers 3, and total possible cases are 6. 3 by 6 to 1 by 2. So everybody will get 1 by 2. So this is not the experimental, this is theoretical probability. So you will have generally the questions from experimental probability in your course. Okay. So before starting that, we should know some type of experiment. Some experiments, and we should know the sample space, event, For example, we have what are the experiments in random experiment? Yeah, there are two type of experiments. One is random experiment that we have to see. We have in our course always random experiment in probability. Random experiment means when we we don't know the result of the result of the experiment is not known. Means, are you understand? When we toss a coin, we don't know whether, for example, if we toss a coin, we don't know whether head will come or tail will come. Means we don't know the result. If we toss this type of experiment, we toss a coin, then we don't know whether head will come or tail will come. Whether head will come or tail, we don't know. Correct? But there are some experiments that are called extrinsic experiments. That in that experiment, we can say that the result will be this one. Let me write. This is theoretical. Okay. So another type is called deterministic experiment, which is not in your course. Deterministic experiment. In this experiment, we know the result. This experiment has done under identical conditions and outcomes are known. Here, outcomes or results, you can say outcomes, sorry, outcomes or results are known. So here we cannot find, we are not doing this one. For example, if you add acid plus some base, you know that what will be the result? You will get salt and water. Acid plus base will give you salt and water. So it is already known, this experiment. This result is always known. So that is called deterministic experiment. So random experiment. So we are doing the random experiment in which if we do the experiment, we cannot say what will be the result. So random experiment, for example, I will give you some examples that we will consider. And for a random experiment like tossing a coin, or tossing uh, number of coins, any number of coins, 100 coins, 1000 coins. Hmm? And the second is rolling or throwing a die or dice, throwing a die or dice. And like this, we have many. If we have in a bag, there are different colors of box, different colors of balls. So drawing a ball from a bag. Yes, one more thing I forgot. drawing a ball from a bag, and you must know about it. I want to know that who don't know about the playing card. So drawing a card, because if you don't know about the cards, you cannot do the probability. Drawing a card, but that is related to the theoretical probability. So in 10th class, I think it will require, or if require, I will tell you here also about the card. So drawing a card from a well shuffled pack of 52 cards, drawing a card from a well shuffled pack of 52 cards. You know that how many cards are there? There are 52 playing cards. So I will tell you about the cards later on. So we have seen that we have random experiment and we have to find the probability in the experimental approach. So it's very easy in your class. So we can take some questions now. If the probability of getting, suppose we have probability of getting the head, probability of getting the head is 1 by 2. Then what will be the probability of not getting head? Not means we write like this, or we can say probability of not head or bar. It will be equal to 1 minus probability of getting head. 1 minus of happening, probability of not happening is equal to 1 minus probability of happening. We can subtract 1 minus 1 by 2. So here it is getting 1 by 2. So here in this question, in a cricket match, a woman hits a boundary 6 times out of 630 balls she played. So probability of hitting a boundary, she hits a boundary, that probability we have to find. So probability of hitting a boundary is given. What? 6 times, favorable cases are 6 times and total balls are 30. 6 by 30. 6 fives are 30. 6 ones are 6. 6 fives are 30. So 1 by 5. But they asked, she did not hit the boundary. That means probability of not. This is not. Probability of not. If we have to find not, we will find first happening. Then 1 minus happening will give you not happening. Probability of not hitting a boundary by her. So boundary will be equal to that I told you 1 minus, formula is 1 minus probability of hitting a boundary, probability of hitting a boundary. Very simple exercise and very simple questions in your class. You can do it easily. 1 minus 1 by 5 and take the LCM. 5 is the LCM. 5 ones are 5 minus 1. So you get 5 minus 1, 4 by 5 is the probability of not. So she did not hit the boundary. Find out the probability that she did not hit the boundary is 4 by 5. Therefore, the probability that she didn't hit a boundary is 4 by 5. Okay, so got it?